we are discussing today this problem. We are given an array. Each element represent maximum length from index I. In other words, if you are at nums of index I, you can jump to any I plus j. So the range of this is j is 0 to nums of I plus j is greater than 1. Okay. We have to return the number of jumps to reach n minus 1. The test cases are generated such that you can reach nums of n minus 1. You are given index array, so you are at this index. You have to reach this index, last index. So how many number of jumps such that should be minimum, and you have to be at this. So the possibility which is this is 1 jump, and from 3 you can go 4. This is what the output 2 is. The minimum number of jumps, the index is to jump 1, index 0 to 1. This is 0 to 1 and 1 to 3 last index. And for this also you can go 1 index and you can jump of 3 steps, so which is 2 jumps, so that is okay. So yes, we do memorization first. Let's think. Let's 2 3 1 1 4. This is 2 3 1 4. So you're at this, so your chances of getting, you have to go here. You have chances to jump here and here. That's one. When you are here, your chances is here, here and here. And when you are here, your chance is only 1. When you are here, only here. Only 1 chance. So how we solve it? So first we create all possible chances. We create all possibilities. Jumping from index I. Now let's say we are at index 0. We are at index 0, which is f of 0. So the possibility to jump from index 0 is, there are 2. You can take jump 1 or 2. So you have to generate 2 possible cases now. So that is the jump 1 and you are staying in index 1, and the jump is counted as 1 and you are staying at index 2. This is 0 1 2 3 4. 0 1 2 3 4. This is, now this is the cases we are generated this case. Actually, if you are at index 1, you are at index 1 right now. So from index 1, the number of steps you can take is 3, at most 3. So jump 1, you can jump with 2 steps or you can jump with 3 steps. So there is a 3 possibilities to get this. 1 plus you are staying at index 2, or you are staying at index 3, you are staying at index 4. And let's see. And right now, if you discuss that you are at position at 2, index 2, which is this, which is this. So the possibility that you can jump from this index is only 1, because here is 1. So you can go 1 plus f of 3, and this is repeated, so you don't have to calculate further this, and similarly this also, both are repeated. So in you are doing memorization, so it's perfect to not to recalculate this same thing again and again. Now we check for f of 3. For f of 3, we are at index 3. So the possibility from index 3 you can jump only one step. So you are reaching. So how we calculate this? So 1 plus f of 4. This is okay. Let's see. Okay. So 1 plus f of 4. So this is also, once it is calculated, so this also can calculate it. Right. So this how the code, when your index reaches 4, where the index is 4, so there is no further jump, so the array is about to bound. So you have to do one thing. You have to stop when our index is about matches this. So we have to stop. Edge case is that if our index, if it is greater than or less than, if it is n minus 1, we return 0. And this is how here gets 0. This is how returns, and it will be returned. So our main aim is so we got all possibilities from generating the index 0. That's fine. And we have to do right now how we get minimum from all these possibilities. That's the thing we have to do. So that's the thing. We define one element steps into minimum steps. This is okay. I am taking it as infinity. When you are comparing with this, indexes, let's say new indexes which are generated from 0, and this minimum steps. So let's say do this. So till here we are fine that okay, the possibilities are got. How we do minimum? This is the case we have to discuss. How we can go for minimum. Mm, How we gonna minimum? I say one thing that I generate a loop. I generate one for loop. One see. I generate one for loop, and which is this is tell as new index. This is new index, which starts from index plus 1, and it goes up to the some farthest point, and we add it. So the general is, so I written for loop here. So what does mean here farthest? Here let's see, here it is index 2. So the farthest means you can go till 2, that is the farthest. If you are at index 1, the farthest distance from this is this. So from index 2 you can go farthest distance 1. So this is the farthest distance. How we calculate farthest distance? It is index farthest distance is it should be of, let's say this is index plus nums of index, and it should not cross over our array bound. So we write a n minus 1 such that our farthest distance should not exceed our array elements. So that's the reason we have written, if our jump is 5 and our index of length is 3, so you cannot take jump 5. So for that reason we retain a farthest distance, and for that reason we consider minimum. So we yes, this is the, I am writing for loop. So generally we start with from 0 index, that's okay, and I am writing a for loop, and I am getting all possibilities to generate everything. From 2 you can go at most this. So from 0th index I am generating all possibilities of further distance we can jump. So that is ni, and such that this is our, and after that let int x equal to. So after when this goes again and the loop runs again, so here x not equal to infinity. If x not equal to infinity, we write minimum steps equal to minimum of min steps of 1 plus f of index. This thing starts when our index star runs from 0, and we return after passing everything, we return dp of n minus 1. dp of n minus 1, which is our answer. Before that, we reach our index last equal to minimum steps, which is our, this is, we can replace it also with index. This is how the code work, and we see dry run of it. We do a dry run. So we have a 2 3 1 1 4. We start with index 0 0 1 2 3 4, and from there is two possibilities. You will jump into on index 1, or you jump on index 2, and from 1 you can, from this you can go this. So 1 plus f of 3, 1 plus f of 4, and after that we see f of 2, the possibility is f of 3. For f of 3, the possibility is 1 plus f of 4. So our index is here, our index is equal to n minus 1, which is 5 minus 1 4 matches. So we stop, and here return value 0, and this return 1, this return 2, this return 3, this return 4. But after that we compare this with, before returning this, we return minimum of infinity comma 0, which gives value 0. So this will be the 1, and when this gives 1, so 1 f of 1 plus f of 3, which gives 2, it returns 2 plus 1, it's written 3, and it's almost, here we go. And at every steps our minimum steps will be updated. Now let's see. At every steps our minimum will be updated. When you are here, so the minimum step will be minimum steps equal to minimum of infinity comma 1 plus x, 1 plus x, which is f of index, which index it is 3, on which index it was generated, on 3, not 1 plus f of 4, I think so. 1 plus f of 4. So this is the 0, and this will be the 1, and minimum step will be updated here. here, and minimum steps will be updated as 1. This returns value 1 to this. No, minimum steps is 1. The 1 plus f of 3 is 4. We generated this minimum step is 1. When you are at f of 3, when you are f of 3, your minimum steps will be when your the minimum steps equal to minimum of which is minimum step is updated as 1, and here 1 plus your index is 3, I think so, which is 2. This 1 plus f of 3, which is 2, and still minimum step is 1. F of 3 will be but the what we have did is okay, we generated everything, and first of all we go this condition, after that this, after that this, after that this, and here we return 0, and we give 1, then it will be 2. It will be 2. So this will be, when you give 3, this will give 4. And this is the one step how it is going minimum, how it goes minimum.